Good morning, students. Today we are going to see some numerical based on Kohlrausch law. The equivalent conductivity of HCl and sodium acetate at infinite dilution are 380 multiplied by 10 raised to the power minus 4 and 80 multiplied by 10 raised to the power minus 4 Siemens meter square per equivalent respectively. The transport number of H plus in HCl is 0.84 and that of CH3COO minus in sodium acetate is 0.56. Calculate equivalent conductance of acetic acid at infinite dilution. So lambda infinity for sodium acetate, it is given 80 multiplied by 10 raised to the power minus 4 Siemens meter square per equivalent. Lambda infinity for HCl is given, that is 380 multiplied by 10 raised to the power minus 4 Siemens meter square per equivalent. We know that lambda CH3COO minus is equal to lambda infinity CH3COO Na multiplied by transport number of this anion. So transport number for this anion is also given, that is 0.56. So put all the values, we comes with lambda CH3COO minus is equal to 44.8 into 10 raised to the power minus 4 Siemens meter square per equivalent. Lambda H plus is equal to lambda infinity for HCl multiplied by transport number of H plus. We have all the values. After solving this, we comes with 319.2 multiplied by 10 raised to the power minus 4 Siemens meter square per equivalent. And we have to calculate lambda infinity, that is equivalence conductance for acetic acid at infinite dilution. So according to Kohlrausch law, lambda infinity for CH3COOH minus is equal to lambda CH3COO minus plus lambda H plus. Both the values are already calculated. Just put that values here and we comes that equivalence conductance for acetic acid at infinite dilution, it is equal to 364 multiplied by 10 raised to the power minus 4 Siemens meter square per equivalent. If the equivalent conductance at infinite dilution for sodium acetate, HCl and NaCl are 91 multiplied by 10 raised to the power minus 4, 426.16 multiplied by 10 raised to the power minus 4 and 125.45 multiplied by 10 raised to the power minus 4 Siemens meter square per equivalent respectively. Calculate equivalence conductance at infinite dilution for acetic acid. Just see, sodium acetate, HCl and NaCl are strong electrolytes and 3 strong electrolytes. So basically this problem is based on method of 3 electrolytes. We know that lambda infinity for acetic acid, it can be written as lambda infinity for sodium acetate plus lambda infinity for HCl minus lambda infinity for NaCl. We have all the values. Just add and subtract. Just add lambda infinity value for sodium acetate and lambda infinity value of HCl and subtract lambda infinity value of NaCl from it. So we directly comes with equivalence conductance for acetic acid at infinite dilution, that is 391.71 multiplied by 10 raised to the power minus 4 Siemens meter square per equivalent. Now we are going to solve third numerical. From following molar conductance at infinite dilution, calculate molar conductance at infinite dilution of ammonium hydroxide. So we have given molar conductance for barium chloride. It is 2.406 multiplied by 10 raised to the power minus 2 Siemens meter square per mole. Molar conductance for barium hydroxide, that is equal to 4.576 multiplied by 10 raised to the power minus 2 Siemens meter square per mole. Molar conductance for ammonium chloride, that is equal to 1.298 multiplied by 10 raised to the power minus 2 Siemens meter square per mole inverse. And we have to calculate molar conductance for ammonium hydroxide at infinite dilution. So according to Kohlrausch law, we can write lambda for barium chloride is equal to lambda barium 2 plus 2 lambda Cl minus. Why 2 is here? Because when barium chloride is dissolved in water, it get ionized and it give 2 chlorine ions. Similarly, we can write for lambda barium hydroxide, that is equal to lambda barium 2 plus 2 lambda OH minus. For ammonium chloride, it can be written as lambda ammonium chloride is equal to lambda ammonium ion plus chlorine, lambda for chlorine ion. And we have all the values which is written here. Now multiply equation number 3 with a 2, then add equation number 2 into equation number 3, and after that subtract equation number 1. So first we are going to multiply equation number 3 with a 2, which is written like this. Right hand side of equation is written like this. So 2 multiplied by lambda NH4 plus lambda Cl minus plus equation number 2, that is this equation is written here. Now subtract equation number 1 from them. So just see what going to be happen. So after putting all the values, we comes with 4.766 multiplied by 10 raised to the power minus 2 Siemens meter square per mole. So this is the value which is come for 2 ammonium 2 multiplied by lambda NH4 plus 2 lambda OH minus, that is equal to this value. So divide, just take out 2 from here or divide both the side by 2. So we comes with lambda ammonium hydroxide, lambda for NH4 plus lambda for OH minus, that is equal to this value. And according to Kohlrausch law, lambda infinity is equal to this can be written as lambda infinity for ammonium hydroxide, which value is 2.406 383 into 10 raised to the power minus 2 Siemens meter square per mole. Now we are going to solve next example. The equivalence conductance at infinite dilution for H plus and acetate ion are 349.8 10 raised to the power minus 4 and 40.9 multiplied by 10 raised to the power minus 4 Siemens meter square per equivalent respectively. The equivalent conductance of 0.01 normal acetic acid was found to be 16.30 multiplied by 10 raised to the power minus 4 Siemens meter square per equivalent. Find the degree of dissociation and percentage dissociation of acetic acid at this concentration. So lambda C is given, that is equal to 16.30 multiplied by 10 raised to the power minus 4 Siemens meter square per equivalent. We know that lambda infinity, according to Kohlrausch law, lambda infinity is equal to lambda plus plus lambda minus. Both values are also given for H plus ion and for acetate, for this acetate ion. So lambda infinity for acetic acid, it is equal to 390.7 multiplied by 10 raised to the power minus 4 Siemens meter square per equivalent. So degree of dissociation is equal to lambda C divided by lambda infinity. We have both the value. After solving this, we comes it as 0.041. So percentage dissociation can be just for calculation of percentage dissociation, multiply this value with 100. So it comes as 4.1%. The specific conductance of saturated solution of AgCl at 18 degrees centigrade is 1.24 10 raised to the power minus 4 Siemens per meter after subtracting that of water. The ionic conductance of Ag plus and Cl minus are 53.8 multiplied by 10 raised to the power minus 4 and 65.3 multiplied by 10 raised to the power minus 4 Siemens meter square respectively. Calculate solubility of AgCl at this temperature. We know that solubility is equal to K divided by lambda infinity. Lambda infinity can be written as lambda for cation plus lambda of anion. We have all these values. Just put all these value in the formula. So we comes solubility S is equal to 0.0104 equivalent per meter cube. Solubility is generally expressed in gram per dm cube or kg per meter cube. Equivalent weight of AgCl is 143.5 gram per equivalent or 143.5 multiplied by 10 raised to the power minus 3 kg per equivalent. So solubility, which is come in equivalent per meter cube, this value of solubility is multiplied by 143.5 multiplied by 10 raised to the power minus 3 kg per meter cube. So solubility is equal to 1.492 multiplied by 10 raised to the power minus 3 gram per dm cube, or it is also equal to 1.492 multiplied by 10 raised to the power minus 3 kg per meter cube. Now we are going to solve next numerical. Specific conductance of barium sulfate solution is 4.17 multiplied by 10 raised to the power 4 10 raised to the power minus 4 Siemens per meter, and that of pure water is 1.16 10 raised to the power minus 4 Siemens per meter. The ionic conductivities of barium 2 plus and sulfate 2 minus at infinite dilution are 127.28 multiplied by 10 raised to the power minus 4 and 100 multiplied by 10 raised to the power minus 4 Siemens meter square per mole respectively. Calculate solubility and solubility product of barium sulfate. So K of solution is given, that is 4.17 multiplied by 10 raised to the power minus 4 Siemens per meter. K of water is also given, that is 1.16 10 raised to the power minus 4 Siemens per meter. So specific conductance for barium sulfate is equal to K of solution minus K of water, which is come as 3.01 multiplied by 10 raised to the power minus 4 Siemens per meter. We know that solubility is equal to K divided by lambda infinity, where K is specific conductance, which is given, and for lambda infinity it can be written as lambda of cation plus anion. So when we put all the values in the formula, we comes with value 1.32 multiplied by 10 raised to the power minus 2 mole per meter cube. Just convert this meter cube into dm cube by multiplying this value with 10 raised to the power minus 3. So for bivalent electrolyte like barium sulfate, Ksp is equal to S square, that is solubility square. So we have solubility value in mole per dm cube, so that is equal to into bracket 1.32 multiplied by 10 raised to the power minus 5 bracket close to the power 2. After solving this, we comes with Ksp value, that is 1.74 multiplied by 10 raised to the power minus 10 mole per dm raised to the power 6. In our next class, we are going to see some other application in conductance measurement. Thank you very much.